students, very good morning to all of you. So, shall we begin the session? In the last class, we have covered some topics of the chapter number 1, that is the introduction to the image processing. What are the various steps that is used for the image processing, or what are the various methods by which we can do the image processing? And today's topic, that is the first topic, is the fundamental steps in the digital image processing. That is, what are the various steps that we follow for creating a digital image, or we can say how to process the digital image. That is the fundamental steps in a digital image processing. So let's begin with this chapter. So that is very helpful, or it is very helpful to divide the material that is covered into two categories. One is for the input. Okay, so wait. Now, let's talk about what are the various steps, that is, what are the various stages that is used for the input and the output, or what are the various brief category of these steps in the digital image processing. So first one is the methods whose input and the output are the images, and the methods whose input may be images but the output are the attribute. That depends on the input and the output, that depends on the input and the output that is given, that depends on the images that is available, that depends on the diagram, that depends on the organization that is summarized. And the diagram does not imply that every process is applied to an image. Rather, the intention is to convey an idea of all the methodologies that can be applied to images for different purposes and possibly with different objective. What are the various objectives that is covered in this one? And the discussion in this section may be viewed as a brief overview of the material in the remainder of the book that is available in the remainder of the book that is used in the digital image processing. And the image acquisition is the first step in figure 1.23 that is available in figure 1.23. And the topic is considered in more detail in this, and where we also introduce a number of the basic digital image concepts that are used throughout the book. And note that the acquisition could be as simple as being given an image that is already in the digital form. So whatever the digital form image that is available in the digital image processing, and generally the image acquisition stage involves pre-processing such as the scaling. So it is a scaling phase that is available with the pre-processing scale that is used with the acquisition stage. Now, image acquisition is the first step, and the next step is the image enhancement that is used to manipulate the image. So one is used for the processing of the image that is recovered, or that is used with the origin of the digital images. Then image enhancement, that is the process of manipulating an image, how we can manipulate the image so that the result is more suitable than the original for a specific application. So what is a suitable application that is used for a specific application that is suitable, or that is used to manipulate an image. And the word specific is more important here because it establishes at the outset that enhancement technique was problem oriented. Whatever the technique that is used, that is a problem oriented techniques. And therefore, for example, a method that is quite useful for enhancing the X-ray images may not be the best approach for enhancing the satellite image. So it depends on the image to image, we can say image acquisition or the image enhancement that is quite useful for the X-ray, and that is also used for enhancing the satellite image. That depends on the image to image. So we cannot say that the X-ray will be used, or X-ray technique will be used for the satellite image. No, that is not possible. And the satellite image also taken up in the infrared band of the electromagnetic spectrum. So first is one is the image acquisition, then image enhancement. And there is no general theory of the image enhancement, and when an image is processed for the visual interpretation, the viewer is the ultimate judge of how well a particular method takes place. So how well a method will be taken out in the ultimate judge of how well a particular method works, that is the theory of the image enhancement. And enhancement techniques are so varied and use so many different image processing approaches that it is difficult to assemble a meaningful body of the technique suitable for enhancement. That means whatever the suitable enhancement that is acquired, that is used for the enhancement in this chapter without any extensive background development. So there is no extensive background development for this technique, and for this reason also beginners in the field of the image processing generally use enhancement application that is used application like the appealing, interesting, relatively simple to understand, So we use the image enhancement, for example, for introducing the new concept that is used in the image creation. And the material in the two chapter that is used in the chapter number 3 and 4, that is also available as a background for the image enhancement. However, as you will see in the progressing through the rest of the world, the material developed in this chapter are applicable to much broader class of the problem, better the class of the problem than just the image enhancement. So let's start again. The next one is the image restoration. That is an area that also deals with, yes, we have covered the image processing, image manipulations. Next one is the image restoration. That is an area that also deals with the improving the appearance of an image. That means how we can change the appearance or how we can change the look and feel of the image. That is a image restoration. However, unlike the enhancement which is subjective, image restoration is also objective. So one is a subjective, that is a image processing. Next one is a image restoration, that is a subjective in the sense that restoration techniques tend to be based on a mathematical or probabilistic models of the image degradation, and the enhancement on the other hand is based on the human subjective nature. That means it is based on the human subjective preference, that is regarding what constitutes a good enhancement result. That means what is a better result that is taken care of with the image restoration. Now next one is the color image processing. That is an area that has been gaining in importance because of the significant increase in the use of the digital images over the internet. So whenever we use the digital image, now more and more demand will be of the colored images. So there is a color image processing that has been becoming important or gaining the importance because of the significant increase in the use of the digital images over the internet. And color is also one of the main factor, and we use generally the RGB, that is a red, green, blue method for the image or the color image processing. The next one is the wavelets, that are the foundations of representing the images in various degrees of the resolution, that is known as the wavelets. And in particular, this material is used in this book for the image data compression and the pyramidal representation, in which the images are subdivided into the smaller regions. So images are subdivided into smaller regions for the reason, or what is the reason that is used for the representing the images in various degree of resolution. And in particular, this material is used in this book for the image data compression and also used for the representation, where the image are divided into multiple regions. We can say the small region that is representable in the program. Now next one is a compression. As the name implies, compression that deals with the technique for reducing the storage required to save an image. That means we can reduce the size of the image, we can reduce the size of the font. That is a compression. So that the name implies that deals with the techniques for reducing the storage required to save an image or the bandwidth that is required to transmit it. And although the storage technology has improved significantly over the last decade, the same cannot be said for the transmission capacity. That means there is no transmission capacity. Sometimes even we face the problem that the mail size or the file size should not be more than the 25 MB, so we have to use a Google Drive for that one. And if there is an image, that automatically takes a large memory, so that also takes a problem in, we can say, the uploading the file, in imaging the file. So that will be, or that would be compressed so that it can be easily rotated, it can be easily gone from one place to the another. And this is true particularly in use of the internet, which are characterized by the significant pictorial content. Then image compression is familiar to the most users of the computers in the form of the image file extension, such as a JPG file extension that we generally use. That one is a JPG, one is a JPEG. Yeah, JPG is one of the, we can say, commonly used format for the compressions. That is image compression standard. That is known as full form is a Joint Photographic Expert Group. Yeah, one more is available, that is a motion picture expert group, that is MPG, that is also used for the compression. Basically, when we talk about the compression, there are two types of compression. One is a lossless, one is a lossy compression. Yes, JPG one of the type of the lossless compression, and MPG is the type of the lossy compression. And morphological processing also deals with the tools for extracting the image component that are used for the representation and the description of the shape. That is, next one is a morphological processing. That means we are using, yes, these are the tools that is used for extract, means taking out the image component that are useful in the presentation and the description of a shape. And the output is also used to process the output image attributes. The next one is a segmentation. That means division. Segmentation, when the term arises, segmentation, that means dividing the terms into multiple parts. That is a segmentation. In general, autonomous segmentation is one of the difficult tasks in the digital image processing, and there is a reused segmentation procedure that brings the process a long way towards successful solution of the imaging problems that requires object to be identified individually. That means the segmentation procedure will be followed up for making the imaging problems. And on the other hand, weak or erratic segmentation algorithm almost always require the guarantee eventual failure that is used for the segmentation that is the most likely recognition to be succeed. The next one is the representation and the description that always focus or that always follows the output of a segmentation stage. That means what is the output representation, what is the output or what is the representation of the output, and the description of the output, that is also one of the part of the segmentation stage, which is usually in the row pixel data that constitutes either the boundary of a region or the points in the region itself. That is a set of the pixels that represents one image region from another, that is representing in the region points also. In either case, converting the data into the form suitable for computer processing is very necessary for the representation and the description. And the first decision that must be made is whether the data should be represented as a boundary or as a complete region. And the boundary representation is appropriate when the focus is on the external shape characteristics, such as the corners and the inflections. And the regional representation is also applicable or appropriate when the focus is on the internal properties, such as the texture or the skeleton shape. And in some of the applications, these representations also complement, we can say, contradict with each other. And we should use a method that should be specified for describing the data so that the features of the interest are highly or highlighted, and the description, that is also known as the feature selection, that deals with extracting the attribute, that means getting the attributes that results in some quantitative information of the interest or the basic differentiating class of objects from one another. That is a description. Next one is a recognition, that is a process that assigns a label to an object. When we use a vehicle, so it will be used for recognition that assigns a label. So we assign a label to an object, that means we can recognize easily, that is known as a recognition. And we conclude our coverage of digital image processing with the development of the method for the recognition of the individual objects, that is known as the digital image processing, that is covered in the digital image processing. And so far we have said nothing about the need for the prior knowledge or about the interaction between the knowledge base and the processing modules. And when we talk about the knowledge about a problem domain that is coded into the image processing system, that is in the form of the knowledge database, this knowledge may be as simple as the detailing regions of an image where the information of the interest is known to be located, therefore limiting the research or limiting the search that have been conducting and seeking the information and seeking that information. And the knowledge base can be quite complex, such as the interrelated list of all the major possible defects that is used in the processing, that is used in the database containing the high resolution satellites, that is in connection with the change detection applications. And in addition to guiding the operations of each processing module. The knowledge base also controls the interaction between the modules, between the database, that is the use of the double-headed rows between the processing modules and the knowledge base that is occur or that occurs as opposed to the double-headed arrow like in the processing module. So when we talk about the double-headed arrows that is used between the processing modules and the knowledge base as opposed to a single-headed arrows that link the processing modules. Whenever we link the processing module, that is carried out with the figure. For example, when we talk about the figure 1.3. Now this is the figure 1.3. This is everything is connected with this one. So it starts with the chapter number 2, that is the image acquisition. This is chapter number 2. Then 3 and 4 is image filtering and the enhancement. So one is the image acquisition, that means we gather the information, we acquire the information, that is the image acquisition. Then next one is the image filtering and the enhancement, how we can filter the image and how we can enhance the image, that is the image enhancement. The next one is the image restoration, how we can restore the image. So one is acquisition, then filtering and the enhancement, then the restoration. After that there is a color image processing, how we can process the how the colored images will be processed, that is the image or color image processing. So one is the image acquisition, then image filtering and the enhancement, then image restoration, then color image processing. Next one is a wavelength. So sorry, that is not wavelength, that is a wavelets and the multi-resolution processing. Then chapter number 8 is compression. That means shrinking the size of the image, that is compression. Then chapter number 9 is a morphological processing, how we can change the structure, how we can build the image so that its structure will be maintained, that is a morphological processing. Then chapter number 10 is a segmentation, that means dividing the same into the multiple parts. So let's start again. So these are the various, we can say, the objects, these are the various outcomes, these are the various procedures, these are the various, we can say, steps that is followed for the image creation, that is followed for the digital image creation, right? Yeah, that forms a part of the digital image creation, and there are multiple images, there are multiple parts, or there are multiple steps. One is the image acquisition, that means acquire the image. Then there is the image filtering and the enhancement, how we can filter the image, what are the various steps that is used to filter the image, enhancement that is taken out. The next one is the image restoration. We can restore the image, we can build the image with the effect of the image restoration. Then color image processing. After that there is a wavelets and the multi-resolution processing, then compression that we have discussed, morphological processing. The next one is the segmentation, then representation and the description. That means how we can represent and what is the description of this one, or what are the various methods by which we can represent the materials. That is options of these processes, generally the image attributes. Then at last there is the object recognition that we have discussed. Now what is a recognition? That means assigning a label to an object, assigning the label to a picture so that it will identify that what we are going to study, what we are going to build up with the development of the method for the recognition of the individual objects. And there is an interaction between the knowledge base and the processing modules, and knowledge about the domain is coded into the image processing system in the form of a knowledge database. So there is a knowledge database that we talk about the public domain, that is the knowledge database that talks about the public domain that is coded into the image processing system. And this image will be quite complex, such as interrelated list of the major possible defects in the material inspection problem, or an image database that contains a high resolution satellite. That means there is a difference between the image that is used for the image database, or that is used for the image resolution satellite of the region that is in connection with the change detection applications. And it is important to keep in mind that viewing the result of the image processing or keeping the result of an image processing can take place at the output of any stage that will display the image processing software. And in the enhancement, or in fact not even all those modules are needed in many cases. For example, when we talk about the image enhancement, For the human visual interpretation seldom that requires use of any of the stages that requires the complexity of an image processing task increases so that the number of processing that is required to solve the problem. So if there is a more complications, we can say if there is a more complexity of an image, the task increases, then the number of the processes are also required to solve the problem. The next one is the components of an image processing system. What are the various components of an image processing system? So as recently as the mid 1980s, numerous models of the image processing have been sold out throughout the world that uses the peripheral devices. Now, my question is, what are the various peripheral devices that is used, or why we are using the peripheral devices? What is the advantage of using the peripheral devices? Why we are going to use the peripheral device? Yes, peripheral devices are the combination of the input and output devices. So that may be any external device, that may be any hardware device, that may be a keyboard, that may be a mouse, that is known as the peripheral devices. And the market shifted to the image processing hardware in the form of the single board that is designed to be compatible with the industry standard buses and to fit into the engineering workstation cabinets and personal computers. And in addition to the lowering the cost, this market shift also served as a catalyst for a significant number of new companies specializing in the development of the software that is written specifically for the image processing. So that is written for the development of the software that is written for the new companies, that is available with a significant number of the new companies that is specialized in the development of the software. And although the large-scale image processing systems still are being sold for the massive image applications, such as processing of the satellite images, then there's a miniaturizing and the blending of the general-purpose small computer that is used for the image processing hardware. And there's a typical general-purpose system that is also used for the image or the digital image processing. And then the function of each component is available with the image sensing. There is an image sensing that is used, and two elements are required to acquire the digital imaging or digital images. The first is a physical device that is sensitive to the energy radiations. So first one is a physical device that will be used that is sensitive to the energy radiation that will be taken out, that will be that we wish to change. For example, if we wish to change, then second is a digitizer that is also a device for converting the output of the physical sensing device into the digital form. For example, in a digital video camera, the sensors produce an electrical output proportional to the light sensor or intensity, and this converts the output into the digital image. The next one is the specialized image processing hardware that generally includes or that consists of the hardware, that consists of the software, that generally includes of the digitizer, that plus the hardware that performs a primitive operation that may be a yes. That hardware may be any primitive operation that, for example, there is a ALU that is arithmetic and the logical unit that performs arithmetic and the logical operations in parallel on the entire images. One example of how an ALU is used in an average imaging that is quickly as they are digitized for the purpose of the noise reduction, and this type of hardware sometimes is known as the front-end systems. In other words, this unit performs a function that requires the fast data throughputs that the typical main computer cannot handle. So it produces the digitized images, it produces the images that are in the digital form that is not produced, that is not taken care by the computer that or typical main computer that handles that. The computer in an image processing system is a general purpose computer and can range from a PC to a supercomputers. In dedicated applications, sometimes custom computers are also used to achieve a required level of performance, but our interest here is on the general purpose image processing systems that is required for the PC type machine that is suitable for offline image processing task. That is a computer. Next one is software, that is any packages. We can say the specialized module that is used for the packages that perform some task or that perform specific task that is known as a software, and there is a well-designed package that also includes the capability for the user to write the code as a minimum, utilizes the specialized module. There's a software packages that also integrate the modules, general purpose software commands from at least one computer language. Then mass storage capacity or capability is a must in the image processing application. That is an image of size 1024 into 1024 pixels in which the intensity of each pixel is an 8-bit quality or quantity that requires 1 megabyte of the storage space. And when we talk about the digital storage for the image processing application, that falls into three principal categories. So that falls into three principal categories. One is the short-term storage for use during the processing. Then online storage for relatively fast recall. Then archival storage characterized by the infrequent access. Then storage is measured in the bytes, kilobytes, megabytes, gigabytes, terabytes. These are the various measurements of the or unit measurements of the memory measurements. And one method of providing the short-term storage is a computer memory. One is a computer memory that is providing the short-term storage. Another is by the specialized boards known as a frame buffer that store one or more images and can be accessed rapidly using at a video rates. Example 30 complete image per second, and the later method also allowed the virtually the zooming as well as the scroll as well as the pan that is used for the frame buffer that is used for the vertical shift as well as the horizontal shift. And the image displays in use today are mainly color TV monitors, and the monitors are also referred to as an image, to as a data file that is also covered in the cell dump that is also covered as a part of the computer system. Next one is a hard copy that is used for the recording images that includes a laser printer, film cameras, inkjet unit, ROM, RAM. These are the various hard copy devices. The networking that is used in the day-to-day life that is used in the computer system because of the large amount of data that is used in the image processing. So the main problem is the transmission of the data that is due to the low bandwidth. In dedicated networks, this typically is not a problem when we talk about the network because everything is controlled via the remote sensing. That is also one of the efficient method. But fortunately, this condition is improving quickly as a result of the optical fiber and the broadband technology that is available within the networking. Then summary of this module, that is what we have covered in this module, that is usage of the memory, usage of the data that is used for the clear impression. So one picture says more than the 1,000 words. This is one of the main code that is available in this module. And we have studied about the various forms that is used in the image creation. So it depends on the coding to coding, it depends on the future application of this technology, although the coverage of this chapter is to the limited. That means coverage is so limited that we are going to cover this module and what we are going to cover in this module. And these are the various references that is used. Next one is chapter number 2. That is a digital image fundamental. So what are the various fundamentals to the digital image that I'm going to start in the Monday's class? That is a digital image fundamentals. What are the various fundamentals to the digital image? Why we are using the digital imaging? What is the main benefit of using the digital image? That is a digital image fundamental. So those who wish to succeed must ask the right primary question. That means what are the various fundamental? That is the main concern. If anyone succeed in the life, anyone succeed in the any point of life. So we'll be taking this chapter number 2 in the next class, that is the Monday's class, that is the digital image fundamentals. All right. So if there is any doubts, any queries, you can add the doubts and clarify